Okay, we're going to do level 2 of trigonometric relations right now. So level 2s are they're little practice problems. So here, sine of theta. This is theta. So that means the opposite. So this would be opposite. This would be adjacent. This would be hypotenuse because adjacent is next to, opposite is across. Hypotenuse is, of course, the hypotenuse. So opposite over hypotenuse is 3 over 5. The cosine would be adjacent over hypotenuse, or 4 over 5. And the tangent would be opposite over adjacent, or 3 over 4. When we look at sine of theta divided by cosine of theta, what we're saying is, what is 3 over 5 divided by 4 over 5? Which we can rewrite as 3 over 5 times 5 over 4, which becomes 3 over 4. So sine divided by cosine is 3 over 4, which of course is congruent to the tangent, which is exactly what we expect. Alright, this one, sine of x. Well, here's x. So for x, this is opposite, this is adjacent, this is hypotenuse. So sine would be 6 over 10, which reduces to 3 over 5. The cosine would be 8 over 10, which reduces to 4 over 5. And the tangent would be opposite over adjacent, 6 over 8, which would reduce to 3 over 4. Now we switch. We look at the sine of y. So here's y over here. So now 8 isn't adjacent anymore, it's opposite. And 6 isn't opposite anymore, it's adjacent. But 10 remains the hypotenuse. So sine of y will be 8 over 10, which reduces to 4 over 5. Cosine of y will be 6 over 10, which reduces to 3 over 5. And tangent of y is 8 over 6, which reduces to 4 over 3. So the conjecture, well, what I notice is that this is equal to this. In other words, the sine of x equals the cosine of y. The cosine of x equals the sine of y. And if you look at the tangents, they're reciprocals of each other. So sine x equals cosine y, comma, cosine x equals sine y, and tangents are reciprocals. Okay, cool. Moving on. There's it says level 3. Everybody, this is a mistake. It's level 2 continued. So sorry about that. I hope nobody thinks that that's actually level 3. Okay, so now we're going to solve for x. So if this is 60 and this is 90, then by the triangle sum theorem, this has to be 30. So that makes this a 30, 60, 90 triangle. So this side is the short side, so that's a, which means z has to be twice as big. So if this is 5, this has to be 10. If this is 5, y has to be 5 square root of 3. So y is 5 square root of 3, z is 10. So then the sine of x is going to be opposite over hypotenuse, or 5 over 10, which reduces to 1/2. 5 over 10 reduces to 1/2. Cosine of x, adjacent over hypotenuse, it's 5 square root of 3 over 10, which reduces to the square root of 3 over 2. And the tangent of x is opposite over adjacent. It starts out as 5 over 5 square root of 3. That reduces to 1 over the square root of 3. But we have to rationalize the denominator. So we get square root of 3 over 3. Because we're rationalizing the denominator, multiplying by the square root of 3 here and the square root of 3 here for the square root of 3 over 3. Sine divided by cosine, this should end up getting us the tangent. So let's take a look. It's 1/2 divided by the square root of 3 over 2. We can rewrite this as 1 over 2 times 2 over the square root of 3. The 2's cross out, we get 1 over the square root of 3. And again, we have to rationalize the denominator, so we do. We get the square root of 3 over 3. And that is this answer, sine divided by cosine, which is exactly equal to what we got for the tangent. So, just as we expected. Okay, now sine squared plus cosine squared. Well, the sine was 1/2, so it's 1/2 squared plus cosine squared, which is the square root of 3 over 2 squared. Well, 1/2 squared, 1 squared is 1, 2 squared is 4, plus the square root of 3 squared is 3 over 2 squared, which is 4. 1 over 4 plus 3 over 4 equals 4 over 4, which equals 1. So, as expected, we got 1 for this answer. Alright, moving on to the next one. We're just going to do the left side. Okay, first thing I notice here is that these are congruent angles. If they're congruent and this is 90, they have to both be 45. So x is 45, z is 45. Now y, if this is a 45, 90, then a and b have to be congruent, so y has to be 6, and this distance here has to be 6 square root of 2. It just has to be, because it's 45, 90 rules. Sine of x, what we get is opposite over hypotenuse, 6 over 6 square root of 2. 6 is canceled, this becomes a 1. We have to rationalize the denominator, so we get the square root of 2 over 2. Piece of cake. Okay, cosine of x. Again, we get 6 over the 6 square root of 2. You see that? The adjacent over 6 square root of 2, we get exactly the same thing, which means the cosine will be exactly the same thing. And then the tangent is opposite over adjacent. If the opposite is 6 and the adjacent is 6, it's 6 over 6, and that equals 1. So sine of 45, sine of x was square root of 2 over 2, cosine was square root of 2 over 2, tangent was exactly 1. Alright, so now sine divided by cosine. It's going to be the square root of 2 over 2 divided by the square root of 2 over 2, which is rewritten as the square root of 2 over 2 times 2 over the square root of 2, which, if you notice, everything cancels. When everything cancels, all you're left with is a big fat 1. So the sine divided by the cosine equals 1, which is exactly the same thing we got for the tangent. So again, no surprises. Okay, now sine squared plus cosine squared. This is the square root of 2 over 2 squared plus square root of 2 over 2 squared. Well, the square root of 2 squared is 2. 2 squared is 4. 2 over 4 plus, again, the square root of 2 squared is 2, and 2 squared is 4. 2 over 4 plus 2 over 4 equals 4 over 4, which equals 1. And again, this question always ends up being 1. We learned that in level 1. Alright, this last one we're going to do. This one looks very familiar to the last one. It's maybe slightly harder. I'm going to show you a little trick. Alright, I guess we need to know z before we can do x and y. So again, these angles are congruent, so z has to be 45. So now notice this. If I was to cut this in half, this distance here would be 2, and this would be 2 as well. Right? And it'd be another 45, 90. We all understand that. So if this is 2 and this is 2, then this is 2 square root of 2. And this, of course, would be 2 as well, making this 2 square root of 2. So it's 2 square root of 2, 2 square root of 2, 4. It's maybe not as easy to understand as the 6 square root of 2, but it makes sense. And as you get used to the pattern, it's not too hard. So anyway, x is 2 square root of 2, y is 2 square root of 2. Now, when it says the sine of z, well, this is a 45-degree angle, so I'd be expecting to get the same answer we got on the last problem. I'd be expecting to get 2 square root of 2 again. Let's see if we do. Sine of z, 2 square root of 2 over 4. 2 square root of 2 over 4. That reduces, it equals square root of 2 over 2. It looked very different, but we ended up getting the square root of 2 over 2 again, just like in the last problem. Cosine of z, adjacent over hypotenuse. Again, 2 square root of 2 over 4, it reduces, and I end up getting the square root of 2 over 2 again. And the tangent of z is going to be opposite over adjacent. So the opposite is 2 square root of 2 over 2 square root of 2. Anytime you have exactly the same thing on top and bottom, you get 1. So, again, we got the exact same things as on the last problem. That's because 45, 90s have these rules. In a 45, 90, the sine is square root of 2 over 2, cosine is square root of 2 over 2, and tangent is 1, always. Alright, sine divided by cosine. Here we get square root of 2 over 2 divided by square root of 2 over 2. That becomes square root of 2 over 2 times 2 over square root of 2. Cross, 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 cross. Everything cancels. We end up with a 1. It's exactly the same as the last problem. And then the sine squared plus the cosine squared, again, exactly the same as the last problem. So it's square root of 2 over 2 squared plus square root of 2 over 2 squared. So the square root of 2 squared is 2, and 2 squared is 4. So it equals 2 over 4 plus the square root of 2 squared is 2, 2 squared is 4, 2 over 4. 2 over 4 plus 2 over 4 equals 4 over 4, and that equals 1. And that'll do it. Okay. Thank you very much. I think some of that may have seemed kind of fast. Just review it. None of it's too complicated. And with practice, it shouldn't be too hard.